I'm Mohib Zara with Hack.Build, and this is my submission for the Hackster.io contest Co-Creating the Future with Intel. My goal is to build it today. I've only got a few hours to do it. For this hack, we're going to be using the Arduino 101, which uses the Intel Curie, and the Grove sensor kit. The reason for that is a lot of people already have these, and it's a great way to go straight to our main goal, which is sensor spike that will live outdoors, have its own battery, a solar panel, the Arduino 101, and you'll be able to connect to it with a mobile app. By scanning a QR code, you'll connect to the Bluetooth device using web BLE, and then be prompted to take an image of your environment and send that image up with the sensor data to the cloud, where it can be used to do analytics, as well as determine what the environment looks like in certain conditions. To make this work, it requires community engagement, and as a reward system, anybody who uses this app and submits this data and an image will be given Bitcoin or a cryptocurrency. So we don't have a lot of time to do this, and I'm going to walk you through my entire process as we build this out. But first, breakfast. I hooked up the Arduino 101 with the temperature sensor and used this basic web Bluetooth example we find in my tutorial to connect to the Curie device and take a look at that temperature in the web browser. Just console logged out here. The value we got was 0 because the heat in Arizona is so hot that it messed up the sensor, and we got a reading of 0. We know we needed a solar panel, and we needed some sort of spike to go at the bottom of the PVC pipe that we're using as the main stem for this project. So we found this for about $34, and it has an awesome solar panel with a battery, as well as a beautiful spike that we can reuse. So that gives us our solar power and our spike. And this, originally, I was going to 3D model a mount, but sometimes it's easier to just go with what you can find. We found this awesome mating piece that connects two pieces of PVC together and has a nice thread in it. We found this bolt, and we were thinking we were going to model and put this in our 3D model. Instead, we're going to use this housing, which has perfectly good mounting holes. So we'll thread this from the other side, stick the Arduino in, and now we have an easy way to mount our Arduino with holes for our wires. And then we'll be using housing, a wire housing, to make sure that things stay safe in the weather. This kind of works out perfectly because we live in Arizona, and you might know this, 3D prints made of PLA just do not stand the heat. I used a pair of cheap calipers to measure the PVC tube so I could model a sensor carriage mount in Fusion 360, which is a really great cloud-based CAD modeling tool. When you're in a time crunch and you have 3D prints to do, make sure those are the first things you start. Glue the plastic bolt to the bottom of the metal mount and screw that into the PVC mating coupler. Take your Grove sensor cable and run it through some of the wire housing and feed that through the holes on the side of the mounting bracket. Open the solar floodlight kit and cut the solar panel's wire from where it meets the base of the floodlight itself. Strip the wire and you'll find two leads. The red is the positive lead. Wire that up to a barrel jack connector and solder the two leads. Then use electrical tape to wrap the two leads such that they're insulated from each other. Use friction tape to make the solar panel's mount fit snugly within one of the ends of the PVC tube. Add the mount that we made for the Arduino previously onto one end of that PVC tube. Take the barrel jack, run it through one of the holes in the mounting bracket, and plug it into the Arduino 101. Twist the mount to wrap the cable snugly around that first piece of tubing. Use friction tape in the same way with the spike so that we can attach it to the end of the other piece of PVC tubing. We've now completed the main assembly for the sensor spike.
Alright, after you've got the main assembly pretty much done, just take the top part off before you mount. Take the spike, in your spot, take a decent mallet, so level with the mallet. Alright, once that's hammered in, stick the top part on. Alright, so we've got this thing completed. I final cut a QR code to go on here. We've got our solar panel and our sensor carriage is all printed up. So this looks this nice thing mount things onto it. Now we're going to test it with the web app here. So running it, you see that it detected that it was the Curie, is the name of the device. Connect. Alright, and now we select the device we want to pair with, and it searches only for the one we want. Pairs, gets the sensor data. And we see the temperature is listed right there, and we can take a picture of our environment, in this case just us, and takes a picture of that and sends that up with the temperature data to a private cloud system. And that's a one-day hack.